Hi guys! In today's video we're going to be talking about properties of operations. So before we get started, you may not remember what a property is. We've talked about it a little bit. A property in math is like a rule. So a long time ago a bunch of mathematicians got together and they experimented with things to see what worked and what didn't and what was true all the time. So things that were true all the time they labeled as properties or as rules. And in this lesson we're going to learn just a few of those rules that apply to addition and multiplication. So we'll see those in just a minute, but before we get started, I want to introduce you to a vocabulary word that's called equivalent expressions. So we know what expressions are. Those are like our math sentences that we've been working with. Equivalent, do you see how it kind of looks like equal a little bit? That's what it means. It means to be equal. So equivalent expressions are expressions that are the same or equal. Okay, now that we have that vocabulary, let's look at our properties. So the first property we're going to learn is the zero property. So what this means is that anything times zero still equals zero. And again, this is one of those rules that mathematicians practiced with, and they found this to always be true. So if I took 8 times 0, for example, I know that's going to equal 0. And that's kind of one of those things you just remember. If I have something that has 8 pieces and I have 0 of them, then it's 0. And this is true for any number. So if I take even like 1,000 times 0, it's still going to equal 0. 1 times 0 is 0. No matter what number I multiply by 0, it's always 0. And we call that the zero property. This next one is called the identity property. So you've probably heard of identity before. Your identity is who you are. It kind of describes you. So an example I've heard is if the secretaries in the office came into class and were trying to find you to check you out of school, how would they know which student they were looking for? So they'd probably have your name and they'd ask for who has that name. That's a way to identify you. So numbers have an identity too. It's their name. So for example, the number 1, its identity is just 1. It's itself. So what the identity property says is we want to find a number that we can add to another number and keep the same thing. So for example, if I have 5 plus some number and I still want to get 5 out, what could I add with that? Maybe that's a little confusing, but if you're thinking about it, I can add 0. 5 plus 0 is still 5. It keeps its identity. Same with, let's try 7. 7 plus what number equals 7? I can only add 0 to make that true. So anything plus 0 stays the same, and that is the identity property for addition. That just tells us that whenever we add 0 to something, it's going to stay the same. Okay, let's look at the identity property for multiplication. Okay, with this one, I'm looking for a number that I can times by another number and keep it the same. So again, if I'm looking at 5, 5 times what number is still equal to 5? Would it be 0? No, because I just learned my zero property. If I multiply by 0, I'm going to get 0 out. 0 is not the identity for 5. I need to think of what number I can multiply by to still get 5, and that number is going to be 1. 1 times any number stays the same. So anything times 1 is going to stay the same as our definition right there. So these are both the identity property, but it's a little bit different for addition and multiplication. With addition, I'm adding 0, and with multiplication, I'm multiplying by 1. And that's just to keep my number the same. So I did an operation on it, but it didn't change. It kept its identity. Okay, the third property we're going to look at is the commutative property. We've talked about this one a little bit before, but not in too much detail. So the commutative property says that we can commute or change the order of the numbers and the answer stays the same. So what that means, commute, that's kind of a big word. Maybe some of you have heard it before. Maybe your parents commute to work or you commute to school. It means to move or to travel. So what that means in math is that we're just going to move our numbers around. We're going to change their order. and our answers will stay the same. So for example, with addition, addition is a property that is commutative. So if I have 1 plus 2, is that the same as saying 2 plus 1? Let's check and see. 1 plus 2 is 3. 2 plus 1 is also 3. So yes, this is one where the order doesn't matter. I can add 1 plus 2, or I can do 2 plus 1, and I get 3 both times. This also works for multiplication. If I do 2 times 3, let's check and see if that's the same as 3 times 2. I know that 2 times 3 is 6, and 3 times 2 is 6. So again, that one works. They're commutative. I can switch the order, I can reverse those, flop their places, and I still get the same answer. Okay, an example of something that's not commutative is subtraction. So I'm just going to write a little note out here to the side. Not commutative would be, subtraction would be an example. For example, 6 minus 4, is that the same as 4 minus 6? 6 minus 4 is 2, but 4 minus 6 is negative 2. Those aren't the same, so it's not commutative. I just wanted you to see a counter example there so you kind of understand this a little bit better. Okay, associative property. That's another big word, and what it means is that we can change the grouping or association of the numbers and the answers stay the same. So association is still a big word. It kind of just means how things are grouped together. So we can change that grouping, and what that means we'll see right here. So if I had, let's say, 4 plus 5 plus 6, and I set that equal again to 4 plus 5 plus 6, okay, I'm not changing the order because it's not commutative, I'm just associating. I'm going to change their groupings. So on this, these look the same right now, but there's no grouping symbols. I could add those in though. Let's say I put some parentheses around 4 plus 5 over here, and I put parentheses over here around 5 plus 6. Okay, now this looks a little bit different, but I still got the same numbers. Remember, if I'm doing my GEMDAS, my order of operations, I have to start with my grouping symbols. When I do that, I have 4 plus 5 right here, which gives me 9 plus 6. And on this side, my grouping symbols tell me to start over here. So I've got 5 plus 6 is 11, and I still have a 4 adding to that out in front. Okay, do these look the same now? No, they don't, but let's see if the answers are the same. 9 plus 6 is 15. I'm going to squish that in here underneath. 4 plus 11 is also 15. So even though these parts ended up different, my answers are going to be the same because addition is associative, meaning my groupings can change, my orders can change, and it still is going to give me the same answer. Again, that's not going to work for all operations, but it does work for addition. Let's check it with multiplication. So let's say I have 2 times 3 times 4 equals 2 times 3 times 4. And again, what I'm changing is the grouping. So I'm going to put parentheses right here around 2 times 3 and over here around 3 times 4. So these are set up different. They are associated differently. But let's see if we get the same answer out. So right here, 2 times 3 is 6 times 4. And over here I have 2 times, and I've got to do my grouping here. I should have technically done that first. 3 times 4 is 12. So I have 2 times 12 and 6 times 4. So right now these look different because their grouping was different, but let's see if they are equivalent expressions. Let's see if they're the same. 6 times 4 is 24, and 2 times 12 is also 24. So yes, these are ones that are equivalent, so multiplication is associative. So looking at our rules here, so our zero property, anything times 0 equals 0. Identity property, it's true for addition and multiplication, but they have different numbers. Addition, if we add 0 to anything, it stays the same. With multiplication, if we multiply by 1, it stays the same. Commutative property follows the same rules for both addition and multiplication. So remember, that just means I write these in reverse order. So I have 1 plus 2, and that's the same as saying 2 plus 1. With multiplication, 2 times 3 is the same as saying 3 times 2. We're going to get the same answer both times, but remember, not all operations are commutative. Subtraction is not, division is not. With those ones, order does matter. Okay, the associative property means I can switch the order of things, the groupings I should say. I can move my grouping symbols around and still get the same answer on both sides. And again, that's true for addition and multiplication, but it won't be true for all operations. Okay, so all you're doing today is you're just listing which property or rule that this is using. You don't have to solve anything, you're just naming which property. So on this one I have 5 times p equals p times 5. So I see that these just flipped places. I don't have grouping symbols, so it can't be associative. And I'm multiplying two different things together. They just switch the order, which is commutative. And this one, because I'm timesing, is going to be the multiplication one. So I'm going to write multiplication right there. Squeeze that in there. Okay, number 2. I see I'm adding, and I have grouping symbols. This one I have 2 plus, and then the 12 plus r in my symbols. And over here, the 2 and the 12 are adding in the symbols with the r on the outside. I switched my grouping or my associations, so this is going to be the associative property of addition. So I'm going to write associative, and then I'm going to write addition underneath, because we like to specify which one we're doing if we're adding or multiplying. Okay, zoom in just a little bit more so you can see this a little better. Okay, this one I see is 0, but is this my 0 property? No, because I'm adding. So 0 plus 5 equals 5. That's not my 0 property. Instead, that one is my identity property, because remember, I'm adding 0 to something and getting the same thing out. My 5 is still a 5 on this side, so that is my identity property for addition. So I'm going to write identity and I'm going to write addition. Okay, let's look at this one. Y plus 3 equals 3 plus y. I don't have any grouping symbols, but instead I flip-flopped the order of these. Y plus 3 equals 3 plus y. So when I move or commute things, that's the commutative property, and this one was for addition. So that's all I'm writing. So over here, that's what you're going to do. You're going to look at these and decide which property it uses. So you'll name the property, so either 0, identity, commutative, or associative, and then you're going to say if it is addition or multiplication. Okay, I'll leave you to pause and try that. See you in class.